Hi guys. Can you all hear me? Uh, all right. Okay. Hi guys again. I hope all of you can hear me and can can hopefully start working. Can you guys please write your names as your student numbers such that it is easily taken into consideration that you attend this session. Okay. Uh, I would like to welcome you to our first session for second semester. And today we'll be doing integration by parts, and we'll be having uh, a number of sessions, or what we call lecture videos that we'll be following up on integration by parts. Without wasting any more time, let us just go through it, guys. Okay, guys. Now, I want you to understand one thing. The most important thing that you need to know about integration by parts. Once you do integration by parts, you need to know let me just write it here. Integration by parts. Guys, this is the easiest. Né? This is the easiest that I'm going to. This is the easiest technique of integration. Okay. What is wrong with my network, guys? If there's something wrong, please let me know. I'll deal with it. So this is what is going to happen. This rule is the only rule that you need to know for you to use integration by parts. Okay. So I have u times v minus the integral of v du. Okay. So everything that I'm going to do, I'm going to refer back to this. This is very important, guys. Okay. This is very, very much. I hope you guys can see what I've written. Okay. You can't know that I can come up with something to help you with the plan. Okay. So I don't want us to dwell too much on understanding where the equation comes from and stuff like that, but I might just give you some light on this one and say to you, this equation comes from this differentiation technique called the product. Okay, so here we are integrating product of two functions. We know that integration is not as easy as differentiation, but there are rules also to differentiation and there are rules also to integration. So integration by parts, it's actually the main rule that we use for integrating product of two functions. Okay, as much as the product rule is what we use to integrate or to differentiate two functions, to integrate product of two functions. So, okay, let me do this. So what's going to happen is we're going to go through a series of examples where we are going to check and understand how this is. Okay. So what's going to happen is, okay, guys, so far, can you see everything that I've written here? I don't want you to.
Yes.
Okay, thank you very much. Okay, so let me put this rule over here. This rule we are going to use it a lot. To have that rule, and you're gonna use it a lot. Okay, let's start with our first example. Let me just see if I can get an example. Actually, let me get maybe 3 examples. Let me see, maybe let us integrate x, then x, okay, and then let's integrate Okay, let me do this. I hope this will change. And then let us integrate another function, x squared e to the x dx. Okay, and then let us take maybe the integral of e to the x sine x dx. Okay, so the integration by parts is just a sophisticated method of substitution. Most of the people, they say, okay, not use substitution, but the substitution. Most people will say that these things are the same or anything like that. They are the same in some way, but they're not really the same. They've got, these ones have got rules that we need to follow. We can't just integrate. Okay, so we need to follow certain rules. In this case, we're going to check what type of rules we have. So let's say, for instance, I'm going to do the first example. So we are given x ln x dx. Okay, I've got two functions there. Do you agree, guys? We have two functions. The first function is x and the second function is ln x. Okay, so it is very important. This is what I usually do, guys, when I solve such questions. Okay, or let me not do this one. Let me do a different, because let us have that. Let's build that confidence. Okay, let us build the confidence, and let us do this one. Let us do this one. Let me say x e to the x dx. Let me build the confidence. Okay, so this is what happened. I've got 4 examples. This one is not related to any of them. Oh, it's related to this one, but yeah. So what's going to happen is we're going to check, okay, which part are we going to call our v part and which part are we going to call our u part. Okay, because remembering that integration by parts, we need to rewrite each and every term by u and v. Okay, now let us look at that. Okay, what I'm going to do is I'm going to say let u be the function that is easier to differentiate. Between the two, which one is easier to differentiate? Okay, so one can say e to the x, one can say x, but most of the people are, I'm sure they're going to say x. Okay, and then we are going to find the derivative of x, which is just 1. So we're going to have that. Okay, and then which means that the second part becomes dv, e to the x dx. Integration of this thing is very, very much simple, guys, because we just integrate on both sides, and it becomes v is equals to e to the x. We do not write plus c here because this is not the final solution. We only write plus c at the final solution. Okay, so this is where this technique becomes very, yeah, it has a lot of rules and stuff like that. So these rules apply because anybody can say that since we integrate, we have to put a constant there. But in this case, we cannot put a constant there because this is way far from our solution. Okay, so we cannot just put a constant. So what's going to happen is we are going to rewrite our what we call our, okay, let me put back this equation. I'm going to rewrite this equation. U dv is equals to u times v minus the integral of v du. Okay, so this is what we have here. So this is what's going to happen. I'm going to rewrite this. What is our u? Our u is this one. So it's x, and then our dv is ex dx. It's e to the x dx. Okay, now we're going to now multiply the two, u and v, and our u is given by that, and our v is given by that. So we have x times the x, just multiplication of u and k minus the integral of what is v. V is e to the x, and then our du is given by this, which is dx. Okay. So the next part that we're going to do is the most critical part about this thing, but yet the easiest thing to do. Okay, because we do know how to integrate e to the x. E to the x stays the same. So then the solution becomes x e to the x minus e to the x plus c. This becomes our final. Okay, so somebody might say, okay, we see what you have done and everything like that, but how to check that this is true? Okay, and I said to you, if anytime you are having a problem where you have to integrate, for you to see whether a solution is true, you must differentiate, which is the opposite of integration. So what's going to happen is going to have d dx of x e to the x minus e to the x plus c, meaning I'm going to take the derivative of this, derivative of that, and the derivative of that. But this is the product rule. So since this is the product rule, we would have x differentiation, or the derivative of e to the x is just e to the x, and I'm going to have plus, so you're going to leave e to the x, the differentiation, the derivative of x is just 1, minus the derivative of e to the x, which is e to the x, plus the derivative of a constant, which is 0. So I'm not going to write it there, okay? So this hence will become x e to the x plus e to the x, because this is just 1, minus e to the x. As you can see, this and that give us 1. Then we get what we have. Okay, are you fine with the idea, guys? I'm just building up your confidence with this one. Okay, is there any question that we have so far? Are we happy? Are we happy with what I was doing? Was I fast, or you want me to repeat something? Please do let me know, guys. But are we fine? Okay. Oh, your silence. I don't like you guys inside, but there's nothing I can do about that now. Okay, let me do this. Okay, so let us continue with our examples. But you guys are awfully quiet. I don't like that, but it's okay. It's okay. Okay, so let me build your confidence again. Okay, let me just build your confidence again. Let me try to do this. I hope you guys have written this thing down, but worry not, I'll upload this to YouTube very soon, later. Okay, before we do these 3 questions, let me just take another one at random. Actually, I'm choosing the ones which are usually used to yeah, which are usually used to trick students. Okay, these are such questions. Okay, now, as I said, when you are doing such questions, you must choose the function which will make you to be able to differentiate much quicker and not have any problems of differentiation. In this case, there is something that you must be very aware of. Have you ever seen the integral of ln x? Guys, please do answer this question. Have you ever seen the integral of ln x? If you have, please do let me know. I wanna.
No.
Okay, thank you, my lady. We have never seen an integral of ln x. So therefore, it is very dangerous for you to choose this one to v, because you cannot integrate this. Okay, so every time, this should be a sign no, guys. Every time you see ln x, you always make this to be your u. Please, guys, né? Because we know how to differentiate ln x, but we do not know how to integrate ln x. Okay, please, guys, please. Okay, so this is what's gonna happen. I'm gonna let my u be equals to ln x. Okay, as I said, guys, please make sure that all the time when you see ln x, you make u be equals to ln x. Okay, so our du equals to 1 over x dx. Okay, and then the second part is what? My dv. My dv is everything that is left, which is x squared dx. Everything that is left is x squared. Okay. So usually, what I usually used to write when I was still a tutor for the previous classes, I would rewrite this as the integral of ln x squared dx and show them that the difference between the two is that this now becomes our u and this becomes our dv because of the definition. Definition said we should always have u and have dv, so it's very important to write it, okay? But with you, I do trust you that much that I just take it from here, seeing that you guys, yeah, are very, very smart. So our v, as we integrate here, becomes 1/3 x cubed, okay? Remember, here we don't put our c, okay? So other people can say, rather than writing this thing, they can just write this as x cubed all over 3, which is still the same solution, okay? Which is still the same solution. Okay, so as we continue, let me remove this part. As we continue, what we're going to do is going to have this, the integral of x squared. Now we said we are going to have multiplication of u and v minus the integral of v d. Okay, so okay, let me just write it down. U times v minus the integral of v d. Okay, so the value of u is ln x and the value of v is x cubed divided by 3. Okay, then the next part becomes minus the integral of v, which is 1/3 x cubed, and then our eu is just this 1/x dx. Okay, so let me show you there's a difference between these two. Okay, so this is what's going to happen, guys. We see that we've got x cubed here and x here, so it becomes x squared. Then we're going to have this as x cubed over 3 ln x minus, we take out this common vector. I mean, not a common vector, but a constant. So sorry about that. Constant 1/3, we have x squared dx. Because remembering that we had a term x cubed all over 3 multiplied by 1/x, and this and that had squared this one just gave us a 1. Okay, so this term just became x squared all over 3, but since the 1/3 is taken out. Okay, so what's going to happen is we're now going to integrate this part. So what we're going to have is x cubed over 3 ln x minus 1/3. Then the integral of this thing is just 1/3 x cubed. Okay, plus c. Okay, so what we're going to write here, we're going to write it beautifully so, and have x cubed all over 3 ln of x minus x cubed over 9c. Okay, so this becomes our final answer, guys. This becomes our final answer. Do you have any questions on this? But if you feel like you want to see if whether this is true or not, you can check. Let's have our check somewhere here. We're going to differentiate this. So we're going to have dx of x cubed all over 3x minus x cubed all over 9 plus c. The derivative of this be product rule. So we're going to have x cubed all over 3 and have 1/x plus, now we leave ln x alone, then x cubed times 1/3 is just 1. So we're going to have x squared. Okay. Do you see where I got that, guys? Do you see why I just wrote x squared? If you don't understand it, please stop me and I'll explain it to you. Then here we're going to have minus. So here we're going to have x cubed. The derivative of this, we're going to multiply by that. We're going to have 1/3 x squared plus the constant, which is just 0. Okay, so as you can see, this one becomes squared, and this will just give us 1. So what we have is 1. Okay, let me write it as x squared over 3 plus x squared in x minus 1 third. Okay. Not write it as 1 third. Let me write it as x squared over 3. And as you can see, this and that will give us 0. And our final answer becomes x squared. And then, okay, I hope you guys get it. So I've built your, this relates exactly to. I hope now we have built our confidence when it comes to integration parts. Now we can go into questions which are challenging or rather tedious. Okay, these are type of questions that I like. I love such questions. So far, guys, are we happy? Are we fine? Is there any question, suggestion, or anything? Please forgive the noise outside. Somebody's complaining about my network. Is my network okay now? If it's not okay, please let me know. Okay. In the absence of questions, I'll continue. So now I want us to do these examples. I've built your confidence now, and I hope now, guys, can see how we can check the solutions too. Okay. So I'll just remove. Remember, guys, video will be uploaded tonight. So I'm gonna send you the link to the video such that you can be able to watch it. Okay. But before I move on to these ones, I just started with the elementary. Let me give you a question that most people want to know how to apply. Okay. Let me say now they give you the integral of let me make it a bit complicated. 0 to -1. No, no. Oh, we can go for -1. Guys, let me make it like this. Because usually just let me have arcsine x. Okay. So now let's say you're given something like this. Okay. And when I introduced integration by parts, what did I say to you guys? I said to you, integration by parts is a product of two functions. And in this case, somebody might say to you, let's say, I only see one function. Okay. The vision that you are going to have will play a role huge. Okay. What do I mean by that? Okay. Me, I'm seeing two functions. Somebody's seeing one function. And it's fine. Okay. It's fine. What am I saying is I'm going to say, okay, let's let u be equals to arcsine x. Okay. And then what is left is my dv, but I'm not going to write it as I want you guys to help me recognize what is our case, remembering that we still have this in mind. Okay, we still have this in mind. So it's very important. Okay, so are we fine so far, guys, with what I've chosen and stuff like that? Okay, if you're not fine, please be ready. Okay, so the derivative of arcsine x, we know that it's equals to 1 over the square root of 1 minus x squared, and then we're just gonna have our x. Okay, so taking this into consideration, guys, do you see what is happening here? We do have this function which we have chosen already, which is our u function, but our dv we haven't chosen yet. And if we can relate this to what I've written here, what is going to be our dv? Can somebody please do us with relations to this? Okay, we have got our u, which is this function. What is going to be our dv in this case? Okay. So none of you know, none of you has an idea of what might be. Okay, let me see. I see somebody in the chat. And somebody says it's 1, which is actually true. Which is actually true. It should be 1. And that 1 should go together with x. Okay, that 1 should go with dx. Because in this case, we said that our dv must go with whatever that has got dx at the end, okay, such that integration might be true for the. So therefore, our v becomes x. I nearly wrote plus c. Our v becomes x. Okay, so we know that the derivative of dv is equal to dx because v is equal to x. Okay, v is equal to x. As the previous example, or the first example, we had our u as x and our du was equal to dx. That's how it goes. Okay, so this is what's going to happen, guys. Since we do have something like this, we're going to write down our equation. And have it as. Now, in this case, I don't want to write the whole thing because I showed you the equation here, integration by parts, u, dv, uv, and all of those things. Now I'm just gonna jump straight into substituting what is and yeah. So we're going to have u, which is arc sine x, multiplied by v, which is x. Then you subtract v, okay, and then have our du. So we're gonna have 1 over the square root of 1 minus x squared x. This is the dx is also part of it. Okay. Okay. So now we have 10 minutes. And then so what's going to happen is from here we're going to have x arc sine x minus the integral of x all over the square root of 1 minus x squared dx. This is what's going to make it more interesting. What is going to happen from here, guys? What do you think? What is the idea that you're going to have if you are given such a question in your test or your quiz or anything? How would you approach it? How would you approach it?
Substitution.
Substitution. Okay. Substitution. So the next question is substitution. What are we going to do? What do we need? I don't know how to ask this question. Okay, what is the value that you're going to use as the substitution in this particular case?
y1 minus x squared is equals to u is 1 minus x squared.
Yeah, but you cannot use u, right? Because we know that u has been used before. So we cannot have 2 different values of u. So what's your name, my man?
Tabel.
So we're gonna use t. T is equals to 1 minus x squared. You remember last semester, guys, I said to you, once you have substitution rule, you always have to, and I specified and I said always have to make sure that you do have you use anything that is under the square root as your substitution name. So what's going to happen is I'm going to have dt is equal to negative 2x dx. Then you're going to divide by negative 2. Then you're going to have dt divided by negative 2 is equal to x dx, which is this part of right here. Okay. So what's going to happen is, thanks, my man, for answering. So what's going to happen is we're going to have x sine x, okay, and then have minus the integral of, so we're going to substitute all of this, 1 over t to the power 1/2 multiplied by dt all over -2. Okay, so which we're going to take out the -2, 1 over -2, so we're going to have x sine x plus 1/2 integral 1 over t to the, so let me just change this as well, because we know that we can write this as t to the t 1/2 t. Okay, are we fine with that idea, guys? If you've got any question, please do let me know. If you have anything that you would like to add or on what I've said, please, yeah, please do not mind it. Okay, so there's nothing in the comment section. Okay, so what's going to happen is now we are going to integrate this part. Okay, and then what we're going to get is x sine x plus 1/2. Now, what is the integral of this? What is the integral of this? The integral of this, we're just going to add 1, then subtract by whatever that is. So we're going to have t. Okay, let me just have this because division is going to be. So you're going to have t minus 1/2 plus 1 all over minus 1/2 plus 1. Okay, we're going to have that is c. Okay, so from here, I'll trust you guys for you to do this and tell me the solution. Oh, no, let me just have x sine x, okay, plus, now if you can check clearly, you're gonna have 1/2, and then this whole term, okay, I'll show you what it's going to have. And I have t to the half, and then we're gonna have divided by 1/2, okay, because -1/2 plus 1 is just 1/2 plus c. So what's going to happen is, for me to change this, I'm going to have to invert the basis, meaning that I'm going to have x sine x plus 1/2 t to the 1/2 multiplied by 2. And as you can see, as you can see, this and that will give us 1. And then now the final answer, sorry guys, I want you to understand. Okay, so now the final answer, yeah, the final answer hence becomes x sine x, and then we're gonna have this. But now we do know what is t. I just rubbed off t. I'm so sorry about this. But however, it's fine because we know that we said this is going to be our t 1/2, then we're gonna have c, because 1/2 is still there, t to the power 1/2. So this becomes x sine x plus the square root of 1 minus x squared plus c. Okay, so in this case, do you want me to check it, guys? Do you want me to check if whether this thing does hold, or am I just, yeah? If you want me to check it, please do it. If you don't want me to check it, you can check it on your own. Okay, so are we fine so far? We're okay with that? Yeah. Okay.
Yes.
All right. Thank you. Or somebody says I should check it. Okay. So let me just do this part. I'm sure you've written this part here, so that I'm confident about doing it. Okay. So the checking part, we are going to differentiate. Okay. But differentiating only the parts. So I'm going to have dx, ddx, or my d that. So we're gonna have x sine x plus the square root of 1 minus x squared plus c. So we know that here we're going to use the product rule. Okay, so the product rule, we're going to have x 1 over square root of 1 minus x squared, and I'm going to have plus, so we're gonna leave this one now, x sine x, the derivative of x is just 1, plus this one, So I'm gonna have 1 over okay, check something here. Remembering that we are having a derivative of the composition of functions. So we're gonna have the derivative of the outer function multiplied by the derivative of the inner function, meaning that we're going to have the derivative of this, which is 1 minus x squared to the power 1/2. Okay, so the derivative is just me multiplying by 1/2, subtracting 1, have this 1 minus x squared, and then we're going to multiply this by negative 2x. Okay, multiplied it by negative 2x, and then our constant is just 0. Derivative of a constant is 0. As you can see, 2 and 2 give us 1. Then this becomes x to the square root of 1 minus x squared plus arc sine x. And we're gonna have minus because of this negative is multiplying here, x all over square root of 1 minus x squared. As you can see, this and this will give us 0. Then my final answer becomes arc sine x, which is correlated to this. Okay. So are you happy with how I think? Okay. All right. So we've got less than 1 minute. Right. So now when we come back, I want to continue